which made us probe whether this was the case earlier. Earlier, of course, for a few hundred years, yes, it was the case. But then it was not the case few thousands and 10,000s of years. So as physicists, so I got trained as a physicist. So I know for sure that there are certain effects which are happening which continuously decelerate the rotational speed of the Earth. So continuously decelerates essentially amounts to saying that the number of days in the year is continuously reducing. So there are studies which, with the sophisticated tools that we have today, that it was more than 400 long back. When I say long back, millions of years back. So there is a continuous deceleration. On the other hand, there are certain phenomena which are happening periodically or aperiodically, which actually accelerates too. And therefore, there is no reason for us to believe that this was the number of days in a year. I'm saying this because I had an occasion to go to National Observatory of Japan, and there they were worried about a certain phenomenon. See, there are certain description of eclipses, so 1,500 years back, and they have noted down certain time. And today, when you compute, it doesn't match with that. So there is enough reason for us to doubt whether the theories that we have formulated is valid for thousands of years back. Okay, so that is the basic idea. Anyway, the point I wanted to make was, it is the motion of these objects which need not necessarily be constant forever determine the time. So the purpose of astronomy is time. Then the second thing is latitude. Latitude is a very crucial parameter based on which you know when the sun rises at your location and when the sun sets. Okay, so this is the most important parameter that we need to know. And this is what they call as desha. Desha means where you reside. Kala is time. And of course, dik. So this dik also plays a very crucial role in designing your own house as to how the light has to enter and so on and so forth. So dik, desha, kala, jnanam. This is the purpose of astronomy. Okay. I'll just leave this also. So this basically gives you a broad understanding of the various branches of science that had been pursued in those days. They used to call as Chaturdasha Vidyasthanam. So Purana Nyaya Mimamsa Dharmashastranga Mishritaha Vedasthanani Vidyanam Dharmasya Chaturdasha. Now, where does this Jyotisha fit in? This Jyotisha actually fits into, see, this. We have Vedaha Sthanani Vidyanam, and you have the phrase called Anga Mishritaha. This Anga refers to Vedanga. Vedanga are 6 in number. Shiksha, Vyakaranam, Kalpaha, Niruktam, Chandaha, Jyotisham. So this Jyotisham is a term that has been employed among one of the Vedangas, but then it basically tells that it is a branch of knowledge which studies the motion of luminous objects. Okay, Jyotihi refers to, so luminosity, and a study of that object, okay, the object, so it's called Vedanga, Jyotisham, okay. Okay. The earliest reference that we find of this discipline is in Chandogya Upanishad. So as many of us know, Upanishads are primarily meant for making us understand your own role with respect to something around you. So Atman, so that is the discipline. But then there are some interesting discussions which we find in various parts, the episodes. And this is an episode which we find in Chandogya Upanishad 7th chapter. The discussion is between Narada and Sanat Kumara. So this is a very famous quote. So Tarati Shokam Atmavit, you find here, see. This Tarati Shokam Atmavit, every teacher of Vedanta will quote this. But then, so Atmavit Shokam Tarati. So the question that is being posed by Narada to Sanat Kumara is, you please teach me. This is how the dialogue starts. So then Sanat Kumara asks Narada, you tell me what is it that you have already learned so that I can take it forward. See, Adhihi Bhagava iti upasasada Sanat Kumaram Narada Tamho Vacha Yadvetha. Yadvetha means whatever you know. Tena mopasida tataha urdhvam vakshyami. So I will teach you further. This is what Sanat Kumara tells Narada. Now, yadvetha, whatever you know, you please tell me. For that, Narada responds, see, in a big way. Rigvedam bhagavodhyemi yajurvedam samavedam asarvanam itihasa puranam panchamam vedanam vedam pitryam rashim daivam nithim vako vakyam ekayanam. So he lists around 20 different disciplines. I have mastered all these 20 different disciplines. And the reason for quoting is, see, in the second line in the second para, the last word, you can see he calls Nakshatra Vidya. So this Nakshatra Vidya essentially refers to what we call as astronomy. Why would you call as Nakshatra Vidya? Simple. After all, if we need to recognize the motion of something, the motion cannot be understood unless you have a frame of reference for recognizing the motion. So if I am seen to be moving, there is a fixed frame of reference, which is the wall, and therefore you are able to see the motion. Similarly, if we have to recognize the motion of the sun and the sun or the moon or any planets for that matter, we need to have a frame of reference. And the frame of reference is actually provided by the fixed stars. So today one may say that the universe is expanding and the stars are not fixed, but then the relative angle that you can see between the stars essentially remains fixed. Okay. So the universe is expanding. It is, there is a principle of isotropy as well as homogeneity. That's a little difficult thing for us to comprehend together. But anyway, so the stars, it is precisely for this reason that we have been able to give a name for a constellation. When you say this Leo, when you say Scorpio, what is the basis? The basis is you see some fixed bright stars. The shape, if you draw the contour looks like a scorpion. The contour looks like a lion, and so on. That is why you give the name to a constellation, a bunch of stars. So they are fixed. They have been fixed for thousands of years. And that's why we have this. So it is this fixed frame of reference which enables us to see the motion of the objects. So our own planets and the sun and the moon. Okay, this has to be very clear. So that is why it is called Nakshatra Vidya. A Vidya which is pertaining to Nakshatra. Okay, Nakshatra literally means that which does not decay, that which does not move, etc. Okay, so this is from a scripture. I told you how old it is. Now, based on some interesting analysis which has been carried out by a person called John Playfair. He was quite a brilliant person, so who lived in the 18th century. So he was a mathematician, physicist, geologist, astronomer, and so on and so forth in University of Edinburgh. And at one point of time, when there was a transmission of knowledge, okay, whatever was done in Europe transmitted, okay, to India and other parts of the world. And then, of course, there will be reciprocation. So once he learned about what has been done here, so he started doing serious computations, very serious scholar. And then it is a 50, 60 page article, so very tightly printed also. And it is titled as On the Astronomy of the Brahmins. So this was published in, see, Transactions of Royal Society, Edinburgh. And there, after doing lots of computations of various phenomena, after all, the science of astronomy is trying to make predictions, right? Prediction means this is the position in which I'll be able to sun here at a later time. This is the position I'll be able to see the moon here. And then only comes eclipses, etc. After all, it is the position of the sun and the moon which you have to precisely compute for you to know when eclipse is occurring. So this science of prediction, which has been undertaken by people here, and the mathematical tools that they had developed, the theoretical framework, seems to have been producing results which was far more accurate than that was available elsewhere. And seeing that it had some extraordinary precision and always better than the other Ptolemaic system, he makes some three hypotheses. One is that it could be sheer coincidence. But then when it repeatedly happens, you can't call it coincidence. Therefore, that hypothesis has to be dismissed. The second one is, see, there had arisen a Newton among the Brahmins. So what does it mean? He essentially says that they had the mathematical tools to compute, as we have today in 18th century, 19th century. But then that was also not there. That also has to be dismissed. And the third hypothesis that he makes is, that's interesting, observations were made in India when all Europe was barbarous or uninhabited. And those made in Europe 5,000 years afterwards come in mutual support. So the point I wanted to highlight was, so his analysis tells the accuracy that has been reached by them in arriving at the parameters seems to be 5,000 years old at least. Okay. So there are texts which also emphasize the need for knowing the mathematics behind what you are doing. So therefore, mere astrologers were strongly criticized. For example, we have this verse, Bhojyam yatha sarvarasam vinajyam rajyam yatha raja vivarjitancha sabhanabhativa suvaktrhina golanabhignyo ganakaha tathatra. So ganakaha means the one who knows merely how to compute. So who does not know the theoretical framework behind that, who does not know the process but merely engages in doing something. So he is strongly criticized by three similes. And astrologer, they were, I told you about this verse, Kala Vidhana Shastram, and then all of the astronomers were seriously concerned. See, the concern was simple. Suppose you have to perform a certain ritual, whether it is stated in Veda or it is for some other purpose in the later literature. So time is considered to be an integral part of the ritual. So of course there is a performer. There are various things that you have to create for doing something, any activity for that matter. Then the time at which it is like this, even in cooking. So things have to be first of all congregated, what has to be added where, etc. If that is not there, then it is not going to turn out to be accurate or precise. And therefore, the results will not be satisfactory. So therefore, time was considered as an integral part of the activity itself. So you have to precisely determine time. So that's why this astronomer, see, Samanta Chandrasekhara, he says, Naste kala vayavakalana yatra drikshastra siddha shrautasmarta vyavahriti chidyate tatra dharma. See, his concern was, chidyate means get shattered. Tatra dharma. See, so all of us know. See, here, I just happen to know. Suppose you are interested in gaining something through stock. The time is the most crucial time. Understand? So if you just miss that few seconds, finished, the whole thing will be gone, right? So similarly, the time, so he says, chidyate tatra dharmaha. Shrauta smarta vyavahriti rapi. So vyavahriti means the worldly transactions, whether it is related to shruti, whether it is related to smriti. So when we say shruti, It has to do with the performance of certain yagas at various points of time. When we say Smriti, so there are various other dharmas. See, so this putra, whatever it is, it can be various rituals in one's own lifetime, various samskaras to be performed at various points of time. So all of them have to be performed on time, and therefore this Shastra is very crucial. Okay, that is the idea. To just give you an idea of the kind of astronomical works, kind of astronomical class of works, there are certain samhitas. This Brihad Samhita, there is something called Brihad Jataka. We have Lakhu Jataka, Jataka Parijata. There are so many kinds of texts. In general, this Jyotisha is Triskandhatmaka, they say. One is Ganita Skandha, the other is Hora Skandha, the third is Samhita Skandha. So Ganita has to do with the mathematical part. So the mathematical astronomy, Jyotisha, I would say, is divided into these kinds of things. I'm not talking about this. Hora has to do with the determination of various times and performance of rituals and so on and so forth. As far as the mathematical texts are concerned, they can be further divided as Siddhanta, Tantra, and Karana. The Koshtaka and Vakyani. Okay. I'll just give you an idea just to know how they proceed. See, the Siddhanta, you might have heard of Yuga, right? So, how many Yugas are there? Chatur Yuga, right? Krita, Kali. So, they also have this durations which are stated. Okay. So, this Kali is stated to be some 4,30,000 years, 4,32,000, 432, simple to remember. Okay, Kali Yuga, 4,32,000. Now, the 4 yugas, they say 1:2:3:4. Okay, so if you add 1 + 2 + 3 + 4, you will get 10. So the 4 yugas constitute 43,20,000 years. Okay, so how did they arrive at this 43,20,000 years? So is it something which is meaningful or not? So is it some arbitrary number which has been introduced? That is not the case. Okay. So this 4,32,000 years, so is a period in which you can see the various revolutions of the planets. They make some integral. Okay. So I will just show that little later. So that is a large period which is chosen for specifying the parameters. After all, if you have to do some computation, you need certain parameters to start with. See, whether it is the gravitational interaction of 2 objects, or it is atomic interaction, so or anything like this. So we need some parameters. We have a model, we put these parameters, we do some computations. So for this, they have conceived of a large period in which they will specify the revolution numbers of various planets, which amounts to specifying the period. Okay, so of moon around the earth, Mercury around the sun, and so on and so forth. So many parameters will be there. If the parameters are mentioned, yeah. So any question, if you have, you please feel free to ask me. See. Yes.
2 questions. Actually.
Yes, please.
So the duration of Kali Yuga, 432,000 years, is well known, but there's some debate on when it actually started. So that's my first question. What are your thoughts on when it started? And the second was, you mentioned about the continuous deceleration of the Earth. So
yes.
It's taking 365
yes.
before.
Yes.
But deceleration means it's moving slower, right? So then it
yes.
will take longer to go around the, so it should be more than 400 days now and not less.
No. No. I'll answer the second question first, then I go to the first question. It's very simple. You have a certain fixed period. So state from here to here. Or let us give you an example which is much more easier to understand. I am supposed to undertake the task of walking from here to the kitchen, let us say. I am given 1 hour. Now, if I walk slowly, how many rounds will I complete? Will it be less or more? If I walk slowly, then so suppose somebody runs fast, okay, a young boy. So he can make, let us say, 20 trips. I can make only 18 trips or 16 trips. So therefore, the deceleration is amounting to less number of days in a year. Year, how is it defined? Suppose one were to ask, as seen from the earth, the sun comes back to the same star. We don't know. See, that the earth is rotating around the sun, revolving around the sun. Even if I were to ask, how do you know earth is revolving around the sun? We have learnt it. But what is the evidence by which I can prove? Okay. So this required a sophisticated device called telescope. Okay. Not that people were a little dumb in those days, but they didn't have the tool. So that requires a very precise measurement. That is all I would like to state now. So that is how we determine. In those days, they defined a year to be sun coming back to the same star. Suppose you want to say the rotational period of the moon, moon coming back to the same star. That is what is called the period of moon. Orbital period is the term that we use, right? So it moves in an orbit, completes the orbit. It's called orbital period. Okay. Bhaganam is the word that they use in English. Bhagana means bham means star. Okay, you count the revolutions. Revolutions are described as bhagana. Okay, the count in the background of the stars. That second question is done. Now let us come to the first question. The first question is, how do we know when exactly Kali began? Okay. Answer is simple. There have been attempts which have been made by people to find in the past when all the planets were sort of together. Together means not exactly aligning to the same, it is impossible, but they were as close as possible. Today, even astrology people study, even Mars and Jupiter are together, this and that are together, 3 are together, etc., etc. They study. So if they are in the same Rashi, even if they are in the 30-degree segment, so you call it as Sanyoga. Okay. So they made some attempt, and around 3000 years back, 3000 BCE, around 5000 years back. Okay. So today, the Kali Yuga cycle is some 5025. Okay. So the 3102 BC, February 17th, 18th, is taken to be the beginning of Kali Yuga. So one attempt that has been made is to get the planets as close as possible. What do we mean by planet? We mean by this Sun, Moon, Mercury, Venus, Mars, Jupiter, Saturn, and then the 2 nodes of the Moon. They will, of course, be 180 degrees apart. Okay, Rahu, Ketu. Now, these objects, which are seen to be moving in the background of the stars, if they align together, see, in fact, the very term Yuga means Yujyante. See, the origin is Yujyante. Yujyante means they are associating themselves, means they are coming close together. Yujyante grahaha. Okay, so this is how the word Yuga itself comes. So this is one thing. And the other thing is, so there are certain records which have been analyzed by people. So the records are generally traced from the description that are found in Mahabharata. Okay. Some eclipses happening together. There are various other things. Mere eclipse will not help you because that is a very frequently occurring phenomenon. Okay. Even 2 eclipses occurring within 15 days is a very frequently occurring phenomenon. But that has to be associated with various other descriptions. And then you try to find out which could be the most probable thing. And that also amounts to something like 5,000 years back. So that is the origin. Okay. Now there are three types of texts, as I was telling you. See, Siddhanta, Tantra, and Karana. I will not get into the details, but I'll just thought I will highlight to you. There are certain texts called Koshtakas, which are essentially tables kind of a thing. And Vakyani is something which is a remarkable attempt which has been made by people. Vakya means essentially sentences. So you have certain phrases in Sanskrit. Those phrases have been coined in such a way that they are meaningful sentences in the classical Sanskrit. But based upon the coding that you have had, you will be able to derive some numbers from those sentences. And those numbers basically give you the planetary positions at different points of time. So this is a very interesting thing that people have attempted. And this particular class of text, Vakyani, has not been so thoroughly studied till now. Okay. Till now, when I say this, recent attempts by a few scholars over the past decades or centuries. So we have not cracked it thoroughly. And this system seems to be as old as 1600 years. And full-fledged development, we are able to see at least by 1400, 1300, around that time. Okay. Okay. And see, the computation of longitudes actually involves precise determination of the value of sine of a given angle. Okay. So how do you determine the sine precisely? Because the mathematical formulation involves sine and cosine function. So we all know, see, we're an electrical engineer. So people of electrical engineering and electronics engineering, they know precisely that the screen that is being displayed here is all essentially dancing of electrons. And it is all this motion of waves, okay, the sinusoidal waves. So the sine function is ubiquitous, and this is playing a very crucial role even in the computation of planetary positions based upon the model that you have created. After all, we create a certain model. Okay, so for studying any phenomenon, whether it is spread of virus, whether it is any other thing, we have to have models, population explosion, whatever. Okay, now this is just to give you a flavor of how the Vakyas are. So if any of you can read, see, Girna Shreyaha, Dhenava Shrihi, Rudrastu Namyaha. So the Girna Shreyaha essentially is, see, 12 degrees, 3 minutes. Dhenava Shrihi means 24 degrees, 9 minutes. Rudrastu Namyaha, as you can easily guess, this is one Rashi, the first number. Rashi is 30 degrees. So 36 degrees and 22 minutes. This is how it goes. The cycle of 248 Vakyas have been created. With this 248 Vakyas internalized by you, committed to memory, you can get the moon's position merely by mental computation. So that's a remarkable thing that they have attempted, which is theoretically very beautiful. And it shows the great ingenuity of these people. Okay. So let me skip this. I'm not going to deal with in great detail. And I also wanted to tell you that there are astronomers, see, who have strongly criticized certain views that are held by Massas. For instance, so suppose one were to say, so the earth is supported by tortoise, etc. Then they will ask, what supports tortoise? Right? So those kinds of some pictures that are there in Puranas, okay? So they have been dismissed by these people. So I will not once again get into the details of that. So then how is the earth held in space and so on and so forth? These are other interesting things. As far as conception of this large period is concerned, see, I don't think any other civilization had that. So many of you may be aware of that. The Siddhanta texts speak of The 1,000 times this 43,20,000 years. This essentially is something which we know. See, how old is this earth, etc. So they sort of, so it stretches our imagination to such large periods. Okay. This is an interesting discussion which has been presented by Aryabhata. You know Aryabhata? Aryabhata was in 5th century. Okay. So his text is the comprehensive text that is available to us today. Before that, there are a few texts I was mentioning, Vedanga, Jyotisha, and so on. A text completely dedicated to the study in great detail is this text. So there he says, Yugavarsha Masa Divasaha Samam Pravruttastu Chaitra Shukladehe Kaloya Manadyanantaha Grahabhaihi Anumiyate Kshetre. It is this last part which I would like you to pay attention. See, Grahabhaihi. Kalaha means time. Time is something which is inferred by us. Understand? The passage of time, whether you use atomic clocks or you use some jumping of some, okay, whatever be the means, it is only inferred. Okay, so many counts have happened. This has happened. So there he says, Graha Bhaihi. Graha means planet. Bham means stars. Anumiyate means inferred. Okay. So this, maybe you are aware, maybe you are not aware. I'll just tell you. So we have something called Sidereal Year and something called Tropical Year. So this is very important because even in astrology, they talk of this Ayanamsha and so on. So there it is essentially this, the time interval between the commencement of the sidereal year and the tropical year. That is what basically amounts to this Ayanamsha, as we call it. Ayana literally means motion. Okay, Amsha is basically degree. Amsha is used part, degree, etc. Okay, so this, as far as observers on the earth are concerned, so we see the sun to be presenting itself in the background of various stars. When the sun goes around the earth and comes back to the same star S1, we call it as a sidereal year. One sidereal year is over. And the number of the period, etc., which has been stated in our text is all sidereal year. It doesn't mean that they did not know the precision. Okay, it is essentially called precessional motion. So the whole thing is rotating like a spinning top. Okay, the axis of the earth. So that phenomenon is something which has been noticed by people. It is also important in computing what we call as Lagna. So they also calculate Ayanamsha even for astronomical purposes. So in marriage invitation, Mesha Lagnam, what does it mean? It essentially refers to a certain period, okay, in which a particular Rashi spends time in the eastern part of the horizon. That's it. Lagna refers to, and it will vary from place to place, depending upon your latitude. The time a particular segment of the ecliptic takes to rise above the horizon is dependent on your latitude, and it will vary from place to place, depending on where you are, okay, and depending upon your latitude. That's a very important computation that they do. Mathematically, it is a sophisticated problem, but they have done some remarkable things in that. Okay, this is just to give you an idea as to how we can pictorially represent what is happening. See? So you are the observer O, and you imagine a tangential plane at your location is what you call as horizon, and any object which is above that, you can see it rising. So in the eastern part, so the earth rotates, as we know today, the objects are going to set. Okay, so that is called west, this is called east. So this determination of direction itself is a Very important problem. Today, many people use this magnetic compass. It's all just meaningless. That has nothing to do with the actual east-west. And the whole thing magnet can flip also. So east-west cannot. Okay. Anyway, this is something which we need to know. So this horizontal plane is called Kshitija. Kshiti means earth. Ja means something which is born out of it. That is an imaginary plane. And this will vary from observer to observer, as you can easily understand. That's why I wanted to show this figure. So if you just see the observer, if you are an observer slightly off, okay. So if you move from here to Memphis, or even so to Newark, so that will be a different horizon. In principle, there are infinite number of horizons. Okay. And the other thing that you have to know is, see the Earth's axis, see, it's spinning, right? So the axis will point to some star in the space. That star is what you call as Dhruva. Dhruva means fixed. Dhruva in Sanskrit literally means fixed. What is fixed, and why do you call only one thing as fixed? Because all the observers, see, so there is only one common pole. So the north pole will go and hit the space. Okay. So any other star, because of the spinning of the earth, will have motion. But there is only one star which will not have any motion. You understand? Every star will rise and set. There is only one star which is along the axis. So either that way or this way, north or south. That will remain fixed. Therefore, you call it as. Now, the problem is, because the axis of the earth keeps spinning, that star itself will not be fixed. Though you may call Dhruva only for some time. And it may so happen that you may not have a prominent star, which you can see also. See, if the axis spins, see, not in every direction you have a prominent star to see, particularly through naked eye. Okay. So there are some interesting discussions in our own Puranas that Dhruva Tara itself is moving, right? It is supposed to be Dhruva kind of a thing. So those are some interesting things which we find here. And of course, just to give you an idea, so since you wanted to know a little bit of astronomy, see, this is, so suppose this is the Earth, so it is some spinning around its axis. This is called a celestial equator. And this is the red line that you see, and inclined to the equator. This is the plane in which the sun moves around the Earth, okay, as seen from the Earth. Yes, please.
On the previous slide, and maybe
sure.
Because I was not able to visualize it.
Sure.
So Dhruva Tara,
yes,
or fixed star, is a northern star, or
we call it northern pole. North. Yes.
Why is southern hemisphere excluded? Why?
Very simple. Nothing exclusion. So most people have been in the northern hemisphere who have been authoring these texts. That is also Dhruva, obviously. So for someone in the southern hemisphere, so that is the Dhruva which he will be able to see. That's it. Yeah. Pardon? Question? Very simple. I'll just tell you. This is the whole sphere that you see is the Earth. Now let us assume that we are in this ashram. This is the observer. So our latitude, let us say, is something. This is the latitude, separation from the equator. Okay. So we assume for the Sailorsburg, let us say it is 45 degrees. Okay. It may be slightly less more. So we are off from the equator by 45 degrees. Okay. And some fellow in Niagara or Canada, he will be positioned here on this pier. His latitude will be higher. Whether you are close to equator, okay, or you are far off from the equator, for all of us, so this axis is common around which the Earth spins. Okay. Now, as the Earth rotates, So you see the object rising and then setting. Every star which is in the space is going to be rising and setting. Okay. So some of them may be seen to be rising and setting. Some of them will be permanently available. So that is depending upon your latitude and the latitude of the star. But anyway, the point is, so there is only one direction in which if there were a star, it will be seen to be fixed. All other things will rotate, okay, around the axis because of the spin. So that particular star, which is directly along the axis of the rotation of the earth, is called Dhruvatara. And obviously it will be two Dhruvas. One is Uttara Dhruva, the other is Dakshina Dhruva. You want to have some question?
Yeah, no, I just wanted to add on. So basically, if you were to draw it from the southern hemisphere perspective,
Yes.
should the horizon be drawn at the bottom as well?
Yes, wherever the location is.
I see. Because I was trying to.
No, very, very simple. Suppose you were to draw, it will be a tangential plane at this. See, if I were to show here, so if you are observer here, your horizon will be this.
Okay.
It is a tangential plane at the location of the observer.
So it is tangential to the spherical position of Earth.
Exactly.
There are multiple horizons depending upon. Okay.
You will be infinite. So as many radius vectors as you can draw, so many tangential planes. That's it. In fact, that will easily explain the variation in the rising time. Okay. For our convenience, we have taken some fixed zones or 3 time zones in US, 1 time zone in India. Okay. So in principle, so for every longitude, okay, so one has to have one, every 1 degree, every 5 degrees, 10 degrees, but that is not practical. Therefore, we maintain some time zone. Okay. This is basically, see, in the previous figure, you see this to be the equator. Imagine this is blown up. Okay. And there is a huge sphere of arbitrarily large radius. Wherever the terrestrial equator, when inflated, will go and meet this large sphere, is what you call as celestial equator. It's an imaginary thing. And now this is a plane. Say this is the Earth, and this will be the equator. This will go meet like this. And this red line basically tells the path traced by the sun as seen by us. Okay. The inclination between this and that is around 23.5 degrees. Okay. So in another projection, this will be like this. And the notion of Uttarayana and Dakshinayana, so is like this. The sun moving from the, so this, they used to call it as summer solstice and winter solstice. S2 will be the summer solstice for people in the northern hemisphere. Okay. S4 will be winter solstice. It will be reversed for people who are below equator. And we call this as Uttarayana, we call this as Dakshinayana. So I'll just quickly tell about this. See, what constitutes Panchanga and how do we understand? So the mathematics behind it. See, the moon completes the orbit around the Earth in 27.32 days. So one interesting fact about the moon is, this is very strange coincidence that, see, the rotational period, okay, of the moon is same as the revolutional period. Okay, it is identical. So whereas in the case of Earth, the rotational period is just 24 hours. The revolution is 365 days. Okay, so that is what is interesting about this moon. Anyway, now, so the moon as seen from the Earth, if it is in line with the sun, you will call it as Amavasya. Okay. And then from here, the moon moves very fast, almost 13 degrees per day. And the sun hardly moves 1 degree. Okay. So when the separation of the moon exceeds that of the sun by 12 degrees, you call it as a tithi. The notion of tithi is very simple. The time taken by the moon to lead the sun exactly by 12 degrees, you call it as a tithi. And this is not something which can be so easily computed to high degree of precision, because the sun is also moving in a non-uniform rate. Moon is also moving in a non-uniform rate. So this is something which they have done some interesting ways of making it fairly accurate. Okay. And the moon, see, when it is exactly opposite to the sun, you call it as a Purnima. Okay. So that is what is, and then once again it comes back. So this is called Shukla Paksha, this is called Krishna Paksha. And this whole cycle. See, the point is, suppose you see the moon here and the sun here, then by the time the moon comes here, the sun will be elsewhere. Okay. So therefore, the period of a lunar month is going to be much larger than the sidereal period of the moon. Okay. It can be by 2.5 days, it can be by 3.5 days. So they are all something which will be varying, okay, depending upon the rate of motion of these two objects. Okay. So no two lunar months will have the exactly same period. Okay. All the lunar months will keep varying. Then there is something called Vara, which many of us know, the weekday. Okay. So that is basically, that has to do with the sunrise and sunset. How many sunsets? If there are 7, I mean, you call one Vara is over. And there are explanations as to why, which day has to be called what and so on. Okay. But so today, let us say it is Tuesday or Wednesday, whatever. So what is the basis of that? See, the basis is not astronomical phenomenon. The Tithi is astronomical phenomenon. Nakshatra is an astronomical phenomenon. Massa is an astronomical phenomenon. Yoga is an astronomical phenomenon, whereas Vara is not. It is just a convention. Okay, so that's it. So that is something which we need to know, the weekday. And Nakshatra and Karana, so I think I'll just leave it at that. So this, so the time is over. Should I just continue or should I stop? Depending on what you say. Okay, I have no issue. Okay. Okay. So this is just to give you an idea of, see, all these are extremely important. Okay. So any kind of computation that you do, okay. See, here you find a few things listed. Just see, sun, moon, moon's apogee. So we all know the notion of apogee, right? When the object as seen from the earth is moving very slowly, okay, the angular separation is going to be slowly increasing. That is, that direction you call it as apogee. And then moon's node, okay. So the motion of apogee, the moon's node, see, the moon's node plays a very, very crucial role in the computation of eclipses. And Mars, Jupiter, and Saturn. These are the things that will be Mercury, Venus, Mars, Jupiter, and Saturn. These are the things that will be listed in the text. Now you see, look at the sidereal period. See, the modern value is 25636. So it is 25868. This is what we find in the text called Aryabhatiyam. Similarly, in the case of moon, see, 27.32166, 27.32167. So this is what they have specified. So to that accuracy, accurate up to 4-5 decimal places. So this moon is something which can be so easily observed in one's own lifetime. One can see some 1,000 revolutions. That is why we have Sahasra Chandra Darshanam. So 80 years celebration and so on. Okay, so this is how they have computed. It is these parameters which plays very crucial role in trying to determine the positions in whatever chakra that you do. Okay, this Rashi chakra, etc., Lagna you mentioned. So all of them are heavily dependent upon the parameters that are specified here in these texts. So Surya Siddhanta will say something. So Siddhanta Shiromani will say something. Aryabhatiya will say something. So which one do you choose? So gives you, see whether it is in this Rashi or it is in the next Rashi. So that is how you actually plug in the positions in the astrological chart. So it is these parameters which play a very, very crucial role. I think I'll stop here. If there is some questions, I can take take on and then.
Yeah, in Metropolitan Museum of Art, there is a mummy, Egyptian mummy,
Mhm.
and on the top of it, they have planetary position, 7 planets only. Rahu Ketu is not mentioned.
Okay.
It says 5,200, 3,200 BC.
Yes.
So this Rahu, when you are saying moon's node, that
Yes.
is Rahu, isn't it?
Yes.
Rahu, Ketu.
Moon's node, Rahu and Ketu, because they are diametrically opposite points, the revolution period is going to be same, and therefore they have specified only one.
Is it true Rahu or mean Rahu? You don't know.
No, very simple. There is nothing like true and false. I would just say that this is something which is known to be moving. It is a very complicated thing. Please sit. I'll just tell you very simply, you can understand. We see the moon to be moving around us.
Yeah.
If you are a close observer, then you will also notice that moon is moving fast. Suppose you just take some instrument and then measure. So you measure the moon's position, let us say at 10 p.m. in the night, and then you measure the moon's position, let us say at 1 p.m. in the night. Now, between these two time interval of 3 hours, you can see that moon has moved, let us say 1.5 degrees in one day. If you do the measurement subsequently, the next day, it might be moving 1.45 degrees. It might be moving 1.56 degrees. Okay, I'm just saying. So this means that moon is moving faster or slower. This is a naked eye observation which people would have done. Therefore, you have to bring in this variation in the speed of motion of the moon into your computation. Okay, I'm saying this because this they have understood to be due to the distance of separation of the moon. So when it is farther separated, it seems to be moving slowly. When it is closer to you, it seems to be moving faster. It is these two directions you call as apogee and perigee. This is clear now. The other thing that they have noticed is, if the moon's orbit were fixed, then once again, when it comes to the apogee, it should have slow motion. Okay. And this direction of apogee also, you know. Direction of apogee means the stars are fixed. Let us say the moon moves slowly when it is in Chitra Nakshatra. Okay, at some point. So later, it will be moving slowly in some other direction, in some other nakshatra. Chitra, Swati, Vishakha, it will just move on. And the slowest motion, wherever it occurs, that direction keeps changing. What does this amount to? This amounts to saying that the orbit itself is moving. So that is what is the moon's apogee's revolution and the moon's revolution. This is clear. The number in the third row is clear now. This plays a very crucial role. And the number in the fourth row is also extremely important with reference to the computation of eclipses. Okay. So we do not have eclipse on every new moon day or every full moon day. So what is this due to? They have clearly understood that the moon's orbit is inclined to the orbit of the sun. So only when it passes through the node and it happens to be Amavasya, then you will have eclipses. That is how the other number comes. Now in the mummy, when you said, so where you don't have this, so this is not a physical object like any other object. Therefore, they might have left depicting it. But this would have been noticed. Or if it is too old, then they were not perhaps interested in the computation of eclipses itself.
But they were timing the event. Basically, they were timing the event that
True.
is unique.
That is very simple. Timing the event has to do with the relative positions of the sun and the moon.
Yeah.
It has nothing to do with the moon's node.
Yeah.
Right? Yes.
Thank you so much for
Yeah.
I have
your
one quick
enlightening,
question.
Yes.
One quick
enlightening
question.
talk.
And anybody online also. Yes, please.
So just to follow up on that, so there's a debate among astrologers whether to use the mean node or the true node.
Yes.
Which one would you recommend?
Very simple. In our astronomical texts, there is nothing like mean and true. In those days, it is a little difficult for them to conceive of finding precisely, because the nodes period, as you can very easily see here, see it is some 6,793 days. So this is a fairly large period and there is no physical object for you to see. The only tool that you have to know where exactly the node is through the occurrence of eclipses. There is no other means. And how frequently you will have eclipses which have a repetitive pattern is not again very easy. So that's why this period of 18.6 years, which is called Saros cycle, and that is not something which is again very fixed. Okay. On the other hand, moon's position, you know the star, you see the moon, very easy. Whereas there is no object there.
Yeah. Anyway,
Huh.
excuse me, that we have to stop. You can talk to him in person. The next class we have to start. So, and the Karve Guruji who was here, he basically always took mean Rahu, not true Rahu. And there are like Dr. Raman took mean Rahu. When there is a lady Jane, she used to come. Her teacher used to take mean Rahu. So the discussion can continue for centuries. Nobody will come. No, that is why you can talk to him later on. We have to start the next class. And thank you so much, Dr.
Yeah.
Ramasubramanian, for your enlightenment. Yeah. So thank you again.
The simple answer is our texts do not have the notion of true Rahu.
True Rahu, we don't.
There is nothing like in the Indian texts, astronomical texts, we don't have the notion of true Rahu. Okay.
Thank you.
Yeah.
Thank you so much.
Thank you.
Thank you, Subramaniam ji. It was so nice.
Okay. Thank you. Thank you very much.
So we will take a 5 minutes break and